In this video, I'm going to review how to use Desmos to calculate area under the normal curve, which are going to give us the population percentages. So this is going to follow lesson 2 or 7.2 on empirical rule and normal distributions. And we've actually worked out part of number 2 on this lesson. So we're going to go specifically through letter J, K, and L and how to use technology to solve those questions. So if I just go to desmos.com, I really just need the graphing calculator. And I'm going to show you how to call up the normal CDF function to calculate these population percentages or areas under the curve. So for letter J, it says, considering that 100% of the linemen are included in the distribution, what percent of linemen weigh more than Marcus? And we want to sketch the distribution for the answer to support the answer. So first we need to know how much Marcus weighs, and that is actually found in letter I. So it says he weighs 275 pounds. And so we actually want to figure out the probability or percentage that the data values or people weigh above Marcus. Okay, so in order to, whoops, my number button is not working. So in order to calculate this, we actually are going to look at this diagram here. And so I've shaded everything from 275 and above. And this was based on the normal distribution given for the problem that has a mean of 284.6 and a standard deviation of 5.3. So we're not required to calculate the z-scores. So that's why we are actually skipping G, H, and I. And so we just need to use technology to calculate all of the area under the curve here. So if I'm using Desmos, I need to know where to go to find those stats functions. So if I go to the keypad and functions, we have some statistical calculations here, but I actually need distribution, specifically the normal distribution. So I'm going to select normal, and it's going to start with what we call a standard normal, which would have a mean of 0 and a standard deviation of 1. So if I did have z-scores, I would want to use 0 and 1 for the mean and standard deviation. But for our problem, we actually have the mean of 286.4, and I'm going to separate that with a comma. The standard deviation was given to be 5.3. So I'm going to type those in, and I actually want to find the cumulative probability, which would be the total shaded area. So I'm going to click this button, and it's going to ask me where I want to start and where I want to stop. So you can think of this as a number line, and this green dotted line actually represents 284.6, which is the population mean. And it looks like I mistyped that. I got this switched around. And so we actually are going to shade everything on this number line starting at 275 and going up to infinity. On the TI-84, there's not really an infinity button, but notice here there is an infinity, and I'm going to type the minimum to be 275. Now, if I didn't have that infinity already filled in, I could just type in the word infinity, and then it's actually going to change that for me. Well, if you spell it right, it will. And so it automatically calculates, and we got 0.9650 if we rounded. So I'm going to type that answer in. And so then we want a percentage for the final answer per the question. And so we would say that 96.5% of the linemen weigh more than Marcus. Now, you can actually sketch this graph. In fact, that's how I created this to begin with. And so I'm going to actually go full screen here, but I would have to change my my scale. So we know that the mean is 284.6. So I need to set those X values pretty big. And so I'm going to choose X values between, let's see, if we move 3 standard deviations below, that's going to be about 268 roughly, and 3 standard deviations above is going to be a little bit over 300. So I'm going to do like 301. And so I'm probably also going to have to change my y-axis. So I'm going to choose -1, and I'm going to go up to maybe 0.4. Okay, so if you look here, this is roughly the shaded area that we had, and then 284.6 would be right in this area for the mean. Okay, now if we look at the next question, it says that we want to know what percent of the defensive linemen weigh between 280 and 293.4 pounds, and then also do the sketch. So if I go back to my Desmos, I can edit or add a new row, and I'm just going to edit this to be 280, and I want my maximum to be 293. So those are the numbers that we're going to be shading in between. And so this total area under the curve would give us the population percentage. So if I write my probability statement, it would be the probability that my values are between 280 and 293.4. So Desmos calculates this very quickly. I get 0.7589, and my final answer needs to be a percentage. So 75.89% of the linemen between 280 and 293.4. Okay, now the final question is going to ask us to determine if a certain golf court used to transport injured players is only rated to hold players up to 300 pounds, what percent of the defensive linemen would need a different card if they were injured? So I still have the same mean and standard deviation. So we can think of this in a couple of different ways. One would be we could calculate, we want to actually know the percentage that is above 300. So one way to do that would be to calculate any of the data values over 300. And I'm going to show you the sketch here in just a minute, but if I look at this curve right here, 300.5 is actually 3 standard deviations above the mean. So 300 is going to fall just below that. So this is likely going to be a very small shaded area of players who would have to have a different card. So one way to calculate that would be to type in 300 for the lower, and then I'm going to use my infinity, and I'm going to get 0.0018. Now, written as a percentage, that's 0.18% of players would need a different card if injured. Now, another way to think about that would be to calculate the lower shaded area and to subtract from 1. I'm actually going to go full screen here, and this is such a small probability or percentage that it's almost not visible. So what I want to do is show you what it would look like to go from on the left tail and subtract from 1. So I'm going to look at a negative infinity, and I just have to type the word. I want to go up to 300. Okay, and notice it's going to give me the same, well, not the same. It's going to give me a different value, but I'm going to take 1 minus that number, which is 0.998167. Okay, and so here is my value that I calculated from before. The reason why this works is because if I look at all of the probabilities under the area or under the normal curve, all of those probabilities add up to 1, which is why the entire shaded area is 1. And so I'm going to go back one more thing here. If I type in infinity, which I think I had before, it actually shows 100% of the curve is shaded.